actually are waves flowing through the cosmos. These birds are real assholes. If the Fantastic Four can produce that kind of energy, the end of the movie makes no sense. I'm Andy Howell. I'm an astronomer, film critic, and science advisor for books and movies. It all comes together on this show, where we use movies as an excuse to talk science, but we also hold movies accountable so they treat science seriously. Today on Science vs. Cinema, Fantastic Four First Steps. We'll start by taking a look at the characters, their superpowers, and their technology. Then we'll get into spoiler territory and talk about the science related to the plot.
Sue, she's always there. Or is she?
Hello, boys. Jesus.
Weirdly, it's the Invisible Woman who has superpowers that are closest to being realistic. You may have seen influencers hyping an invisibility cloak. This is just a Lubor's lens. It takes light rays coming from an oblique angle and projects them forward. It's similar to a Fresnel lens, which are used in some lighthouses to turn a spherical light source into a straight beam. But it only kind of works straight in front of you for an object right behind it. So it isn't real invisibility. We have stealth aircraft that are almost invisible to radar, but those work by reflecting radar waves off at odd angles. That's not true invisibility. For that, you need to take light from behind an object and wrap it around what you're trying to hide. This has been achieved kind of. In 2006, researchers were able to hide a cylinder using a cloak made of metamaterials with a complex small-scale shape. But that was only possible at a specific microwave frequency, and it won't work with optical light. People have used mirrors to deflect light around something, but that only works if you see it from one direction. And then there's the trick of using cameras and a video screen to hide something. That was the principle behind James Bond's car in Die Another Day. That was done with movie magic, though Mercedes did attempt a version in 2012 as a stunt, but it only worked from one side and it wasn't going to really fool anyone. There are creatures who have come closer to achieving invisibility than anything humans have accomplished. Cephalopods. Octopuses, squids, and cuttlefish can disguise themselves by mimicking their backgrounds. Check out this octopus surprising a diver.
I have to admit I was screaming when I got this video thing.
They do this by manipulating chromatophores, special pigment-containing cells. So something approaching invisibility is theoretically possible, just impractical right now. The Invisible Woman can also project force fields. They're kind of like a magnetic field, but for forces. It doesn't seem like that will ever be possible, but that's okay because it's a staple of science fiction. Mr. Fantastic can stretch his body to incredible lengths and into absurd shapes. There are some creatures who can really stretch and contort themselves when they need to. Cockroaches can squeeze down to a quarter of their body height. And octopuses can really stretch their arms and squeeze through all kinds of small spaces. Some species can even balloon up like Mr. Fantastic himself. But those are invertebrates. What about something with a skeleton? Mice can fit through some really tiny spaces too, only limited by the size of their head. And there are even flying snakes, which can flatten their bodies to create lift. Skeletons really limit you here, which is why in the comic books they sometimes hint that Mr. Fantastic doesn't even have one. He's just like a big old bag of goo. They really do say that. Like he sleeps in a bucket and all this stuff, yeah.
Like Odo?
Yeah, but then there's other ones that say he does have a skeleton. It's not nonsense. Anyway. The Thing has rocky skin and super strength. Maybe the modern creature that most resembles him is the pangolin. It's the only mammal covered in scales. They're made of keratin, which is what your fingernails are made of. It's kind of like if an anteater became the Thing. But for a better example, we have to go back in time. Ankylosaurs and nodosaurs are families of armored dinosaurs. Nodosaurs had regular tails, but ankylosaurs had mace-like clubs on the end. The best preserved nodosaur is one of Borealopelta markmicheli. It's a remarkable specimen because its scaly skin is preserved, as well as some soft tissue and even the contents of its stomach. And the coolest thing is, it wasn't flattened, so we can see its 3D shape. It was about 18 feet long and 3,000 pounds. Its armor is bony plates covered with keratin, about 6 inches thick. Researchers were even able to uncover some of the pigments from the skin, and they think it was kind of a reddish orange on top and white on the bottom. And they estimate that it could survive a crash with a speeding truck. That sounds a whole lot like the Thing to me. So how would the Human Torch's powers work? The secret is that you have to burn fuel above the skin so that your actual skin doesn't catch on fire. This trick is used by stunt people when they light themselves on fire. They have special clothes and a special gel. The gel acts as a barrier, partially blocking heat while an accelerant burns on top. The Human Torch can also fly. To do that, you have to have thrust like a rocket. So he has to have more fire coming out from his feet than the rest of his body. I like that you can see that in some scenes in the movie. Besides humans, there aren't really any examples in nature of creatures who can create fire. There are a lot of mythical firebirds though, including the phoenix. As for real birds, while they can't create fire, Australia has several species of firehawks. They pick up burning sticks from a fire and drop them other places to create new fires to flush out prey. These birds are real assholes.
I herald Galactus.
What is that?
Galactus is a super being who sustains himself on the energy he gets from destroying planets. From basic physics, we can calculate how much energy it would take to destroy a planet. The binding energy of any planet is given by the formula G times m squared over r, where G is a constant, m is the mass of the planet, and r is the radius. For Earth, that comes out to about 200 nonillion joules, or 2 followed by 32 zeros. That's a lot of energy, about a billion atomic bombs. In the real world, planets can be destroyed, but it's rare. In about 5 billion years, our sun will puff up and become a red giant and swallow Mercury, Venus, and maybe even the Earth. But even before stars get to that stage, some of them devour planets if one gets kicked out of its orbit and wanders too close to the star. We've seen evidence of planets being melted away like this. We can't resolve the planet with our telescopes, but we can see that when the light of the star is blocked by the planet, there's a gradual dimming or brightening of the starlight, indicating a comet-like tail. And in some cases, observations with the James Webb Telescope have indicated that the material melting away is the rocky surface. So planet destruction is real. It just usually isn't done by giant dudes in purple suits.
So the surfboard, is that part of your body, or is that...
Why does the Silver Surfer, a cosmic being from another planet, use a surfboard to cruise through space? Well, the real reason is because his creator, Jack Kirby, was tired of drawing spaceships, and he wanted to capitalize on the surfing craze. But the comic book reason is because the surfer just wants to be free to appreciate the cosmos and be unencumbered by a ship. That's a sentiment I can get behind. Even though there's no water in space, there actually are waves. Anytime heavy objects like black holes move, they create distortions in space-time called gravitational waves. They stretch and compress space on scales much smaller than an atom, and yet we can detect this effect. There are 2 giant laser interferometers in the US called LIGO and one in Europe called Virgo. They can detect black holes or neutron stars merging together in other galaxies from the waves they make in space. In 2017, I participated in the discovery of the first kilonova.
A long time ago, in a galaxy far away, 2 neutron stars merged together.
The merger of 2 neutron stars that created a black hole. Physicists at LIGO and Virgo told us the region on the sky to look by triangulating from the gravitational waves, and we pointed our telescopes at the galaxies there until we found a new type of explosion. These waves aren't big enough for the Silver Surfer to be surfing, but who really cares? Space surfboards are just cool. Still, it's pretty astounding that there are waves flowing through the cosmos. It's inconvenient when only one member of your team can fly, so the rest of the gang has to schlep around in the FANTASTICAR. Now, more than 60 years after its conception, we still don't have flying cars. The autoplane from 1917 didn't really work. Then there was a triphibian vehicle from 1935 whose demo went worse than a Tesla's. There was a helicopter thing from 1940 and the Corvair Model 118 from 1947, basically a car and a plane smashed together. There are loads of more modern versions, but they all share one thing in common. Lots of hype to attract investors, but no mass production. These things need to cost more than a small airplane, so we're talking hundreds of thousands to more than $1 million. But what you get is something far less capable than an airplane, because without a pressurized cabin, it can't go very high where airplanes need to be to get anywhere efficiently. This is the technology of the future, and it always will be. Fantastic Four launch and land their rocket ship from right outside their headquarters in New York City. This is a profoundly stupid idea because a disaster would result in mass casualties. This has happened. In 1960, there was an explosion of an intercontinental ballistic missile on the launch pad of the Baikonur Cosmodrome in Soviet Kazakhstan. The head of that rocket program, Mr. van Netelen, and dozens of engineers and technicians died because they were too close to the launch site. The Soviets covered it up until 1989, but they eventually admitted that 54 people had died, although other estimates put the number of casualties in the hundreds. After learning from that mistake, all countries launched their rockets with as few people around as possible.
Whoa! That's not good.
There's another reason not to launch from New York. Rockets usually launch to the east from as close to the equator as possible. That's because you get a big speed boost from the rotation of the Earth the closer to the equator you get. That's why US launches are usually from Cape Canaveral in Florida, which is at a latitude of 28 degrees north. New York is at about 41 degrees, so it takes more energy to reach orbit from there. Sometimes satellites need to be in a polar orbit for Earth observation. In the US, those are done from Vandenberg in California to launch south over the ocean. If satellites aren't in polar orbits, virtually all of them are orbiting eastward in the direction of the rotation of the Earth. But in the movie, they show the Fantastic Four ship orbiting in the wrong direction. That's just needlessly dumb. Okay, now we're going to talk about spoilers. So the characters would get to space and then just immediately be weightless. It's a common misconception that weightlessness comes from being in space, as in outside the Earth's atmosphere. But weightlessness has nothing to do with the air. It's because astronauts are in free fall. When they're in orbit, they're constantly falling towards the Earth. It just so happens that they're moving forward at a rate that they constantly miss the Earth and they fall around it. Gravity comes from acceleration, or a change in velocity. Any mass, like the Earth, will cause an attractive force to act on another mass, like your body. That force causes an acceleration. The strength of that acceleration on Earth is what we call 1g. When we accelerate upwards, we experience more. Apollo astronauts experienced as much as 4 Gs during liftoff, which is like weighing 4 times as much. Galactus' ship clearly has some kind of gravity generator because they were walking around in it, but when they left the ship, they were still accelerating, so they shouldn't have started floating. Our heroes take a trip to a neutron star, the closest thing to a black hole that can still emit light. They're one of the most incredible things in the universe, akin to an atomic nucleus 10 miles wide, but more massive than the sun. Low on fuel, the Fantastic Four decide to do a gravitational slingshot around one to get home. That is not the way it works. Real space probes often swing by another planet to get a boost in speed, just like how Voyager 2 went by Jupiter, Saturn, and Uranus before speeding on to Neptune and beyond. That works not because of the gravity of each planet, but because the spacecraft is boosting off the planet's motion around the sun. It's like being on a bicycle and grabbing a speeding car. The neutron star looks a lot like the black hole in Interstellar. It wouldn't look exactly like that, but that is the least of our problems. The neutron star is only at most 2 times the mass of the sun, while the supermassive black hole in Interstellar was 100 million times the mass of the sun. Interstellar was conceived by Kip Thorne, a Nobel laureate, who did real calculations to make sure you could survive around such a black hole and the time dilation would be accurate enough to drive the story. It took a team of dozens of scientists and artists to create a real simulation to show what was on screen, and that produced 2 scientific papers. Counterintuitively, you're more likely to survive a supermassive black hole than a neutron star. For a massive black hole, the point of no return, the event horizon, is really far away, where tidal forces that would rip you apart are weak. And any matter flowing around these things speeds up the closer it gets, like water flowing down a bathtub drain. Stuff disappears into the black hole before it can really pick up speed. But for a neutron star, the matter can get much closer so that it's whirling around near the speed of light. That friction heats it to enormous temperatures, tens of thousands to millions of degrees. That causes them to emit X-rays, so getting anywhere near them would melt you, irradiate you, and rip you apart from tidal forces. Everyone in that scene should be dead. Also, somehow the Silver Surfer, despite being only a few feet closer to the neutron star, is sucked in and trapped there for a month while the Fantastic Four can escape. That makes no sense from either time dilation or energy arguments. They say they have to reach 88% the speed of light to escape. I started to do some calculations about that, but then I realized, oh, that's just a reference to Back to the Future.
88 miles per hour!
Fine, but words have meaning. To accelerate a spaceship of that size to that speed would take 10 to the 24 joules. which is thousands of times more than humanity produces in a year. If the Fantastic Four can produce that kind of energy, the end of the movie makes no sense. So you want a set piece around a neutron star. Here's how to do it better. What if Susan Storm figures out she can bend not just optical light, but X-rays, and she bends them around the ship, protecting them? Johnny Storm's control of fire helps them survive the intense heat. Reed Richards knows more about neutron stars than the Silver Surfer.
Trust me.
And he lures her so close, she's affected by the neutron star and is incapacitated. The Thing uses his imperviousness and super strength, aided by Reed Richards, to go out of the ship and rescue her. So the mutations they got in space now protect them, and they teach the Silver Surfer compassion. That's better science, better drama, and better reinforcement of character.
She was right here, and Johnny thinks they had a moment.
The Fantastic Four intercept communications from other stars, and some of those are from the Silver Surfer's home planet in her native language. Johnny Storm then asks her to translate a single phrase, which he hears in space, by the way, and then uses that to translate all of those messages into English. This is so stupid on so many levels. Johnny Storm likens it to the Rosetta Stone, a tablet from around 196 BC that enabled the translation of ancient Egyptian after it was found in 1799. It had 3 parts, the same text written in Greek, more casual Egyptian, and hieroglyphics. Working with a whole lot more material, it took professional linguists decades to do the translation. To have a dumb superhero do the same thing in a few months from one sentence is a slap in the face to linguists and thinking people everywhere. Here's how they could have done it better. Established that Galactus and the Silver Surfer have to use Herbie to translate, but he's reluctant to do it, like C-3PO in Return of the Jedi.
Artu, you're playing the wrong message.
Then Herbie teaches Johnny the language. That defines Herbie better, and it preserves Johnny Storm's character, who's anything but a genius in the comics. The subject of how to communicate with aliens is fascinating though. Some symbolic attempts have been done, like the records sent on the Voyager spacecraft, which are now in interstellar space.
I wish to extend greetings and friendly wishes to all who may encounter this Voyager.
Or by transmissions to other stars. If you're interested in this topic, check out our Science vs. Cinema episode on Arrival, a movie that treats the subject matter with the respect it deserves. This whole subplot about teleporting the Earth is absurd. Normally I wouldn't quibble about the energetics of a superhero movie being impossible, but this is the movie's own math. They have an experimental technology that can teleport an egg across a table. That consumes the entire energy output of New York City for a few seconds. The record peak demand for electricity in New York City is about 34 megawatts. A watt is a measure of power, or energy divided by time. It's a joule per second. So in 3 seconds, the most energy the city of New York has ever produced is about 100 million joules. Earth is 10 to the 26 times more massive than an egg. That's 100 million billion. It should take 10 to the 34 joules to teleport the Earth. That's a 1 followed by 34 zeros. If you add up all the energy humans have produced in the history of the world, you're still short by a factor of billions. It's worse than that because generally speaking, utilities lack the capacity to store significant amounts of energy. When you need it, they have to make it right then. So all this stuff about saving up energy is total nonsense. Now they somehow get all of humanity to come together to assemble insanely complex technology in a few months, and they're going to gamble dissolving the Earth and all the people on it and moving it to another star? And this plot point is totally disposable. It just doesn't matter. Here's how to do it better. Reed Richards knows about wormholes since their ship appears to use them. Have him make one and skip all that nonsense about teleporting the Earth and saving energy. That's fewer extraneous concepts to introduce and more efficient storytelling.
And now I'll look back.
Finally, a Fantastic Four movie nailed the vibe, characters, and the universe they belong in. These feel like the comic book heroes come to life, and there's plenty to like. But the science is not so great. Here's the principle I use when evaluating science fiction. You get to bend the physics and the science to set up your world and the heroes, but if you're talking about something in the real world, don't get it wrong just because you didn't understand it or didn't ask an expert. If filmmakers talk to scientists, they can create something astounding that no one has ever seen on screen before. But if they just rip off other movies, they're doomed to be derivative at best, and at worst, make their movies ridiculous and transmit their own misconceptions to millions. damage that can last for generations. It's fine that the Fantastic Four have unbelievable powers and they live in an alternate version of the 60s, but then the filmmakers go and do stupid things like making a useless set piece around the neutron star that doesn't even make dramatic sense, much less physical sense. The same thing goes for the subplots about Earth teleportation and linguistics. They're just unforced errors. Every scene could have been made better by talking to a science advisor. That doesn't just mean making the science better, it means making the story better. If you like this show, please subscribe and check out some of our other episodes. You can also find us on Instagram and TikTok.
There's a reason it takes like 8 years to get a doctorate in linguistics. It's actually like really complicated.
I had to talk with the physicists. I'm like, okay, great. Okay, I see why that makes sense. Why should anyone give a flying?
I don't think you'll be able to use this. This is too physics geeky.
Yeah, that's something I've spent zero time in my life as a linguist thinking about.
How do you talk to an alien? I guess the right answer is carefully.